And in the previous video, I was talking about the differences between a single job and array job. I talked about one of the examples of a typical script. How does it look like? It has a resource header, and then following the resource header, there are the instructions, are actually the commands that will be getting executed on your data. So in this video, I'm just exclusively will talk about a single batch job, how the script looks like, and I will talk about one particular example. So generally in single jobs could run you have a large data set, you can split into smaller chunks, run over multiple CPUs and get incremental solutions, combine them to get the final solution. This may not necessarily be all the time be a case. It depends upon what algorithm, what program you are running. Some programs support multi-threading, some of them don't. So one has to look at the manual to figure it out whether it supports multi-threading or not. If it doesn't support multi-threading, then it essentially is going to run on one CPU. But if it supports multi-threading, then I would say it's a good thing to take advantage of that, and then use multiple CPUs to process your job quicker or faster. This is one program, this one particular example which I'm going to demonstrate is basically running FastQC, which is a quality check on your FastQ files, which is your sequencing short reads or short read sequences, and you're going to run it over through a FastQC command to check at the quality of your reads. So it's a single batch job. Essentially, we have a problem. We're going to split into, it supports multi-threading, so we can have two CPUs running it. So we can have running basically split into two chunks, each chunk running separately and incrementally, and then we combine to get the final solution. Again, the resource header, it's much less in number of lines being mentioned there, but that's entirely up to you what all you would like to include it. For example, I don't have here the emails added here, but if you would like to get notifications through your email, you can add your email ID here. So the first line is again what's the interpreter we are using. Then what job, name of the job will be FastQC. Number of tasks is 1. CPUs per task, that's the lowercase c. This is the long version of the -c flag. This is the longer version. Dash CPUs per task is 2. This is the dash lowercase n, which is 1. Most of the bioinformatics softwares would be 1. Memory, we need 2 gigabytes because it's a very small file. Partition we are using is MCB student, and quality of services is again MCB student. So this part on the top, what you see of a part of a script is the resource header, which we are specifying in terms of like which partition, which QoS, how many CPUs and other things. Now, in terms of you're looking at -o and -e, which you remember is to collect standard output and standard error. Rather than having a specific name, I have %x underscore %a dot out and %x underscore %a dot err, which is the error file. The %x gets replaced by whatever your job ID is. So your job ID name is FastQC. So it's going to be FastQC underscore, and %a is generally your job ID number. So every time you submit a job, whether it's an interactive session or it's a batch job submission, the scheduler is going to assign space to you and keep track of that particular job, and it keeps it basically gives a job ID to that particular job. That job ID is a number. That number is going to be assigned here. So you essentially the output file will be FastQC underscore job ID number dot out, FastQC underscore job ID dot err as your error file. The first one is your standard output. Second is your standard error. So this is pretty much your resource header is. I include in my scripts always a host name, so I know where my job was running. So if for some reasons if job fails, I can go back and check if there is an issue with the compute node or it's an issue with my script. And sometimes if there is an issue with the particular compute node not running, or particular software not running on a compute node, I would like to go back to system admin. I would like to provide him as much information as possible. So I have to tell him, specify that, okay, this is the compute node on which my job was running. Date when the job started, date which is job ended. Here I'm using module load to load FastQC. That's the FastQC is the command that comes out of this particular package. So I'm loading that particular module. I'm just creating a directory where my output should go. And this part is essentially the command. FastQC is the command which comes from FastQC package -t2. That's the number of threads, or basically the number of basically splits I'm making of my data sets. It's just like two CPUs over here. That's what actually used by dash t. Now in some programs it could be dash p, in some programs this could be number dash dash CPU. So you have to look at the manual of the program. So here, if I want to find out what is the flag, I would look into the manual of FastQC. And in FastQC manual, dash T represents the threading, multi-threading, or CPU. So that's why I use dash T, and then two. I'm using two. I'm splitting into two parallel processes, and this has to match with the number of CPUs I am requesting over here. Because if I want to run on two CPUs, I should have asked for two CPUs in my resource header. This is where my output is gonna go, and this is my input file is. So this is essentially a script would a single job script would look like. So let me show you how in on the cluster looks like. So I'm still on an interactive session. So first let me open basically look into the contents of fastqc.sh. That's the script which I have created, which is essentially exactly the same information. What you see inside the slide is exactly here. There's no changes whatsoever here. And so what I'm going to do here is I'm going to submit this script or run this script as a job, as a batch job. So let me come out of here. So because I use less command, I'm going to hit Q for quit, and I come out. And the command I'm going to submit, it's now I want to submit this job. So I'm going to say as batch, or I'm going to type as batch fastqc.sh. That's the script I want to run. This is my input file, and this is my output, where my output should go. Now after this I will hit return, and I'm quickly going to type a couple of commands. I'll explain what each one is. Okay. Okay, right, that's good. So I submitted a script which is as batch fastqc.sh. The moment I hit return, it gave me that it has submitted a batch job and gave me the job ID number. That's the job ID number I was talking about in the script, that every time you submit a job, the scheduler assigns you a job ID, and the resource manager keep a track of your job using this particular ID. And you can also look into the status of your jobs by using specific job IDs. Next, I ran a command called asq. This command is very specific to Slurm. It tells you which all jobs you are running, which all jobs are actually right now going on or you submitted on the cluster. So it shows me two jobs. One, it is showing basically the first one is definitely the FastQC, which I just submitted. And it tells me that this is my job ID number. This is the partition I'm submitting the job. This is the name of the job. This is the user, which is me, and the status is showing me PD, which is like pending. The reason may be that the resources are right now not available on MCB. Student partition is waiting for those resources to come available. So that's why it's showing status as PD. And time, once you start running, the time will increase. Right now, because it's not assigned to any compute node, it's not telling me where my job is running. But it's giving me another one over here. And that particular job is bash. So this is my interactive session, which is, you can see I'm Xanadu 67. I'm running an interactive session. So that's the ID of my interactive session. It was through the partition general. It's a bash, the name of the job, and it has been running for last 55 minutes, and it's running on Xanadu 61. So let's do one more SQ, hopefully. Oh yeah, so now I don't see that job being listed here. So if you see your jobs being here, it possibly have moved from PD to R state. R state is like running. The job would have run and then completed. So since I don't see that job listed here, my I can either my job has successfully completed or it hasn't encountered an error. So let's have a look at what has gone through. So now, as I mentioned, it has created the error channel file is this one. The standard output channel file is this one. So you can say less. I'm going to open this one out. So it's always a good idea that once you submit a job, your job finishes, you look into your output files, standard out and standard error channel output, just to see if there are any errors. So here it tells me that my job ran on Xanadu 71. That's the output of the command host name in my script. Then this is the date command. This is the part of the FastQC, and that's again the date at the end of it. So there's no error whatsoever. Now let's check the ERR file. And you see there is an ERR file. There is some sort of an basically display, some content is there, but nowhere it says that it's an error. It's just telling me the progress of my command. Now, ideally, I would have expected only errors here, but sometimes the bioinformatic commands are written in such a way that some of the output goes to the error channel, because you can write the commands that way, that you can specify where the output should go. So for example, in FastQC, the command is written in such a way that the progress should go through the error channel. So that's why it comes to the error file. What I would be looking here is like keywords like error or failed or basically collapsed or something like that, which indicates that my program has collapsed. I don't see that. That essentially means that my command has successfully executed or the script has successfully executed. So we look at some of the commands like SQ and other things. There is one more thing I would like to like to point out is quickly, because I submitted this job, there's one command which is quite useful, is called SF, and essentially what it tells you is the efficiency of your resource usage. So we specify 2 gigabytes of memory and 2 CPUs, how well those resources were used when we executed this command. So the way to do that is SF space the job ID number. So you take this job ID number, that's what we ran just now, and it gives you some stats. Now it tells you the job ID number is this one, and what I'm looking here is it's used 62.5% of the CPU. So efficiency usage, that's decent one. Now when I look at the memory usage is essentially very low. It says 0.07% of 2 gigabytes, which is like really small amount. Now in terms of cluster, I think if you're using a memory something to 5 GB, 10 GB, and your usage is that low, that's fine. That you don't have to worry about. The place where you have to worry about, let's say if I ask for 200 gigabytes and my usage is 1%, I'm overkilling it. So in those scenarios, what I would do is to reduce my memory usage, basically the request resource from 200 gigabytes or 100 gigabytes to maybe let's say 10 or 5 gigabytes, depending upon. This can give you, basically it gives you how much memory it utilizes. So you can just take this one and maybe add 25% more to it, and that's the memory is good enough to run your job. Anytime if you submit a job, let's say for example, and let me clear it out, and I'm going to run SQE again. It tells me the job. This is my interactive job that is running. Anytime let's say you submit a job and immediately you realize, okay, there's something I didn't do properly with my job and I want to kill it and to stop it, so the command is scancel. You do scancel and you specify a particular job ID number. So I don't want to kill this one because it's an interactive session, but let's say the previous job was that one. I want to kill that particular job. I would have done that, and it would have stopped that particular job from running, or basically wherever it has gone through some extent, it will stop immediately over there. If you want to cancel all the jobs, let's say you have hundreds of jobs, you don't want to find out each every job's ID number, you can cancel all your jobs using command scancel. Then you specify -u, which is user. Cancel all the cancel jobs of user, and then you can specify your user ID, and you hit return. It's going to cancel all the jobs, whether they are interactive or whether they are submitted jobs. It's going to cancel all the jobs whatsoever. There is another command I would like to, since I'm here, basically we are here, we can discuss about is to look more detailed information about your job. You can say as control show job ID, and then you give the job ID number, and what it does, it gives you a detailed description of any job that you have run. I have run a script, so it's giving me details about what script I have run. Even if the script is running at that particular point, if you run this one, it's going to give you some details. Sometimes the key things you are looking here is the end time. So when you're running a script, it will tell you like how long your job has been running, and generally on our cluster a script should finish by 21 days, otherwise it's automatically get cancelled. Some bioinformatic application can take up to 2 months or possibly more than 21 days. So it's a good idea to keep a track of your job. If you see that the end time of your script is coming closer and is going to it's good to get in touch with us by cbc support@ucon.edu, and we will extend this particular job for whatever time period you would like to. But the key things is going to give you a very detailed information about any job that you have submitted. it also where your error file is located, where is the out file is, where the script is located. All those details are out here. So it gives you much more detailed information about with respect to that. So any other command? I'm just thinking, like you said, any other command that's basically crucial for your so sf, sq, scancel, scontrol show job ID number. These are possibly 3 or 4 commands which will come across. You will be using more often to submit the jobs. So yeah, this is pretty much with respect to a single job submission. So the next thing which we are going to talk about is the array job submission.